Hello everybody, hope all of you are well and safe. Today I'm going to explain chemical reactions of alcohol. The objectives are explain alcohol's reactivity and mild oxidation of alcohols. Let's begin with alcohol's reactivity. The reactivity of alcohols can be caused essentially by the polarity of bonds OH on the one hand and CO on the other hand. Let's start with OH. OH is polar bond, which makes alcohol behave as a very weak acid. Let's see how. The ROH here, the O is partially negative, the hydrogen is partially positive. Now the alcohol has the ability to donate the H plus and it becomes RO minus plus H plus. So we call it Bronsted acid. Also, the CO is polar bond, where the known pair of electrons on the oxygen atom can add a proton H plus and makes the alcohol behave as a very weak base, which is Lewis base. So alcohols are amphoteric. They can either be an acid or a base. Recall the substances that are also amphoteric. They are water and bicarbonate. Now the second objective is mild oxidation. Now let's begin with the definition of mild oxidation. It is a mild reaction which takes place without breaking the carbon chain. What does it mean? If the carbon chain of the reactant consists of 4 carbon atoms, in the product it stays 4 carbon atoms. The carbon chain here does not break down. So, also mild oxidation of alcohols can be carried out in 3 ways. The first one is catalytic oxidation in the presence of oxygen gas, which is present in air. The second mild oxidation is catalytic dehydrogenation in the absence of oxygen. The third one is oxidation by oxidants such as dichromate and permanganate. Note here that in this presentation we will discuss number 1 and 2. So the number 1 is catalytic oxidation in the presence of oxygen gas, which is in air. Catalytic oxidation in the presence of oxygen gas is divided into 3 types. The first one is mild oxidation of primary alcohols. The second one is mild oxidation of secondary alcohols. The third one is mild oxidation of tertiary alcohols. Let's start with the first mild oxidation. We start with primary alcohols are reductants, so they are oxidized to aldehydes and or carboxylic acid in the presence of a catalyst Cu, so which is copper. Now let's see here the primary alcohol which undergoes oxidation. Yani it means it is oxidized by removing the H here and the H from the OH, and in the presence of the oxygen, half O2 or 1 oxygen, and in the presence of copper, to become an aldehyde where the same carbon is bonded now to oxygen, and we still have the hydrogen. يعني this C double bond O is the aldehyde functional group. This functional group of aldehyde C double bond O is called carbonyl group. Now here notice that you have the functional group of the primary alcohol is on the first carbon atom. The functional group of the aldehyde is also on the first carbon atom, plus H2O. This is the first equation. Now, upon continuous mild oxidation, the aldehyde still have one hydrogen. Okay, so it can be oxidized in the presence of oxygen to give OH. So here we have the C double bond O stays as it is, and on the H we have the oxygen. So what do we get here? This H will become here OH. So as a result, we get here the functional group of the carboxylic acid, which is C double bond O OH. So the aldehyde becomes carboxylic acid. Now, if we want to add the two equations, 1 and 2, we get the overall reaction as we have here. Now, primary alcohol, now, and we have half O2 in the first equation, half O2 on in the second equation. Here both of them are on the reactant side, so we can add them. If we add two equations in the same substance on the reactant side, we can add them. Now look at the aldehyde. In the first equation, it is on the product side. The same aldehyde is in the second equation on the reactant side. So in this case, we subtract them and we don't have any more aldehyde. The overall reaction will be primary alcohol plus O2. In presence of copper, we get carboxylic acid plus H2O. This H2O is from the first equation. So these two reactions are exothermic, which is referred to as the flameless lamp process because it is exothermic. Now, application on primary alcohol. Let's take ethanol that consists of two carbon atoms. The first carbon atom holding or bearing the OH, it is called functional carbon atom, and it is also holding or bonded to one R and two hydrogen plus half O2. The product will be aldehyde, where you have the C double bond O on the first, also on the first carbon atom. So the OH here will become the OH of the functional group of the alcohol will become C double bond O, which is the functional group of aldehyde. And since here it is on the first carbon atom, so we call it aldehyde. Now, how do we name this aldehyde? This aldehyde consists of two carbon atoms, the same as the alcohol. So it ends with Al. You see here, ethanol ends with Ol. The ethanol ends with Al. Now, upon continuous mild oxidation, the ethanol plus half O2, what does it become? This double, the functional group of the aldehyde C double bond O will become C double bond O OH. It is ethanoic acid. The functional group of the ethanoic acid is C double bond OOH, which is called carboxyl group. So here we have primary alcohol gives aldehyde and the aldehyde gives carboxylic acid. Now let's take another application where we have a branched branched on the main chain. Now the branch here is CH3, and we have also primary alcohol because the first carbon atom bearing the OH has 2 hydrogen and 1 R. What do we call this branched alcohol? We call it 2-methyl-1-propanol. In the presence of half O2 and presence of copper, the functional group of the alcohol OH will be aldehyde of functional group C double bond O. Now what do we have here? The branch stays the same, and the product will be called 2-methyl-propanol. Okay, now upon continuous mild oxidation, the 2-methyl-propanol will become 2-methyl-propanoic acid. What do I want from you here is to pay attention to the branched that is bonded to the second carbon atom. This branch stays in its place, in its position. It does not change its position. It is on the carbon, the second carbon. It stays on the second carbon. So don't forget that the branched is kept on the same carbon atom. Now the second objective is mild oxidation of secondary alcohol under the same conditions as those of primary alcohols. The mild oxidation of secondary alcohols ceases or stops upon formation of the corresponding ketones. What does it mean here? That we don't have continuous mild oxidation. Let's take an example, a 2-propanol that consists of 3 carbon atoms. The second carbon atom bearing the OH has 1 hydrogen and 2 R. So it is secondary alcohol plus half O2 in the presence of copper. What do we get here? The second carbon atom will have the carbonyl group, the OH. So what do we have here? OH, it becomes C double bond O, and we notice here that the C double bond O is not at the extremity of the chain, it is within the chain, so it is called ketone. How do we name this ketone? Since it consists of 3 carbon atoms, we call it propanone. It ends with ONE. Now, the third one is mild oxidation of tertiary alcohol. Tertiary alcohols do not undergo mild oxidation. Let's take the example. You have the tertiary alcohol where the carbon bearing the OH has the 3R. So this 3R hinders the formation of the product in mild oxidation. So the carbon here can't hold 5 carbon atoms. That's why 5 bonds. That's why no reaction takes place. Now the second one is catalytic dehydrogenation in the absence of oxygen. Now this catalytic dehydrogenation, let's take it with respect to primary alcohol in the absence of oxygen, leads to the formation of an aldehyde. So if we take now another example, which is 1-butanol, that consists of 4 carbon atoms, the carbon at the extremity holding the OH is bonded to 2 hydrogen and 1 R. In the presence of copper and temperature 300 degree, there will be removing of 2 hydrogen atoms to form hydrogen gas and aldehyde. So the OH here will become C double bond O at the extremity of the main chain. So the primary alcohol gives aldehyde plus H2. This reaction is endothermic since it needs a very high temperature, 300 degrees. So the catalytic dehydrogenation of a tertiary alcohol in the presence of oxygen, in the absence, of oxygen, leads to no reaction. So here the OH, it becomes C double bond. As a summary, class of alcohol, we have primary alcohol. Upon mild oxidation, the product will be aldehyde. The product of continuous mild oxidation will be carboxylic acid. With respect to secondary alcohol, product of mild oxidation will be ketone, and there is no product of continuous mild oxidation. With tertiary alcohol, no reaction in mild oxidation, and the product of continuous mild oxidation also no product, so no reaction. Finally, I hope that you understood everything. If you have any question, I'm ready to answer. Thank you.